Hi, this is our 5760 final project. I'm Michael.
Drew.
I'm Jacob.
We designed a Pokerbot that was running on the FPGA. So the basic kind of method of how it works is it does a Monte Carlo based simulation. So what that really means is it performs a lot of simulations of your hand and the potential other hands that other players have and what could be coming down on the flop to turn in the river, and then spits out a probability that corresponds to the number of hands that you're actually likely to win. Using our pipeline and our design, we were able to achieve basically maybe 1,000 to 5,000, depending on how generous you are, speed up over the HPS alone, and then about a 10x speed up based on Jacob's actual laptop,
Which is
the
a
C code.
Intel i7 6700.
And which poker game were you playing here?
Playing Limit Texas Hold'em.
Okay.
Limit Texas Hold'em is where the bets when you raise are a fixed amount based on the blinds. This way that our Pokerbot doesn't have to decide how much it wants to raise. It can just decide raise, call, check, or fold.
Mm-hmm.
So what actually happens on each hand? Like what do we send? What happens?
Right. So for each player gets, like, they're all running as a Pokerbot. You can play up to 9 other players, and each turn they'll come to them and say there are 3 cards in the community pool and they have their 2 hole cards. Basically what will happen is we'll do a shuffle, and then we'll do a ton of shuffles, sending them into the pipeline, 300,000 different hands, and it'll shuffle the deck, distribute that out to the 9 players that you don't know what their cards are, and the rest of the community cards, determine whether or not you've won this hand, and add it to a running counter. And it'll push through as many of those as it can, up to a certain number, and count up how many you've won, and sends that back to the HPS, and it'll display the probability on the screen. If you're playing, and for the computer, it'll just send it back to the HPS, and the bot will make a decision based on the thresholds that we've designed.
So you're basing it on a ensemble of some 300,000 or so hands each time around to calculate. Okay.
So you can actually play a game of poker as well. So we can run the program here. You can decide how many players you want to play against.
3.
We'll just do 3 total. You can put in your name.
That's
Maybe.
a great name.
And now what happens is it tells you your cards, and so right now the pool starts empty. There's no cards on the table. All you know is your cards, and right now, a priori, you have a 30% chance of winning. At this point, it seems like a pretty good hand. I'll raise. And you can see all the computers just call on the first round. So now once the card comes down, you see there's now 3 cards in the pool, and you have 2 cards in your hand. So what's going to happen is it will take these known cards, it's going to send them over to the FPGA, where the FPGA will run through 300,000 hands of what all the other players might have, what the next 2 cards might be, and it decides that you have a 14.35% chance of winning. So that's kind of sad. So I'm going to call there and not go up.
We can see the computers on their turn. Drew Jalen Brown has raised to 6, and Sally Hand Sandwich called to 6.
Yeah, so that's my turn again. It's still not looking great, but I'll just call. I'll stay in. Okay, so now we've got the 4th card down, and wow, this is really not looking good. I have
3.
just about nothing. I'm gonna
So you're on a
fold.
6%.
About a 6%
We're at a
chance
6%
of winning
chance
here.
of winning.
I'm gonna fold and bail. And the winner is now Drew Jalen Brown.
So once you fold, it'll just run through the rest of the game with just the computers, because you're not in it anymore. So what happened was Drew Jalen Brown raised to 10 after you folded. Sally called, and then Drew Jalen Brown raised again, and Sally called again, and then they had their cards come down and whatnot, and so then the winner was Drew Jalen Brown, and he won $28.
Cool.
Yeah.
And you can see the cards that were still on the table at the point of winning, so you can actually verify that the winning is correct. We also print out the average time per computation. So those 300,000 simulated hands took about 150 milliseconds each time.
Wow. Okay, thank you.